Hey everybody, so in this video I'm going to talk to you about the concept of the Bohr atom. So for right here we have the nucleus in the center, and these circles are different energy levels. So the closer you are to the nucleus, you have greater energy. So n is equal to 1 has more energy than there is here at n is equal to 4. And so let's say we have an electron. And so the electron orbits the nucleus. This is a 2D model. In this 2D model, we show that the electron is moving around the nucleus in circles, but in reality, they are shells. So the electron would be moving across the surface area of that shell that it's in. It's kind of hard to show that on a 2D paper, but that's how it is on a 3D model in reality. So let's say an electron is right here at n is equal to 1. As it moves across these different energy levels, starting from n is equal to 1, moving to an n that's greater, it is absorbing energy. So let's say n is equal to 1, the electron is here at the first energy sublevel, the first energy level, and then it goes all the way to the fourth energy level. It absorbed energy, a specific amount of energy. And then once it falls back down, so it's bouncing back down, it doesn't matter to which energy level it falls back down to, but as long as it's falling back down, it emits energy in the form of light. And there are some equations that describe the energy that is emitted or absorbed, and then the wavelength of the light that's emitted. So a particular equation, E, which gives you the amount of energy that was absorbed or emitted, is equal to B, which is a constant, times 1 over the final n squared minus 1 over the initial n squared. So this constant right here is a negative constant. It has a value of negative 2.18 times 10 to the negative 18. So let's just conceptualize this for a moment. Let's say the electron starts at n is equal to 1 and its final destination is at n is equal to 4. When you plug that into the calculator, so you have that constant right there, and then we're multiplying that by, so I said the final is n is equal to 4, and that squared would be 16, minus 1 over the initial, which was 1 squared, which is 1. So 1 over 16 minus 1 over 16 is a small decimal. It's like less than 0.1. And when we subtract that by 1, we're going to get a negative value. And then once you multiply that by the negative constant, you're going to get a positive value. So you get a positive value when you go up the energy level. So from n is equal to 1 to a greater energy level, or n is equal to 2 to a greater energy level. And that positive value that you get once you plug in the values for this equation means that energy was absorbed. Now, so let's do this in reverse. If we started at n is equal to 4 and we go back down to n is equal to 1, you're going to have 1 minus 1 over 16, and that's a positive number, times that negative constant. You get a final negative answer. So that negative answer means energy was emitted, and that energy is emitted in the form of light. And there's another equation that calculates the wavelength of that light that was emitted, and it's similar to that equation for the energy, which is 1 over the wavelength times a constant, and then 1 over n final squared minus 1 over n initial squared. But that's just we're just conceptual.